Okay, class, in this video I'm going to show you how to simplify expressions using properties of radicals. So first thing we want to do here is use the properties of radicals to rewrite this as the cubic root of 5 divided by the cubic root of 9. Now I know that 9 is 3 times 3. If we could somehow make that 9 into a 3 times 3 times 3, which is 27, then the cubic root of 27 would be 3. So what I'm going to do is I'm going to multiply both sides, both top and bottom, by the cubic root of 3 and the cubic root of 3. That way we could have here the cubic root of 5 times 3, which is the cubic root of 15, divided by the cubic root of 27 and the cubic root of 27, which is the cubic root of 15 over 3. And this is exactly what we need to do when we simplify expressions. We try to leave the expressions with no roots, no radicals on the denominator. So keep that in mind. The next one would be the fourth root of 81 divided by the fourth root of 16. And so the fourth root of 81 happens to be 3, because 3 times 3 times 3 times 3 makes 81. The fourth root of 16 is 2. So this one didn't require any simplifying. Okay, to simplify the next set of problems, the ones that look like this, again, we don't want radicals on the denominator. There's something interesting about the way we do these ones. In order for us to do that, we need to first define what a conjugate is. So if you have something that looks like this, the conjugate, it's this. It's exactly the same numbers, but with a negative sign in between. So for example, 3 minus the square root of 5, the conjugate would be 3 plus the square root of 5. And something really interesting happens when you multiply the conjugates. When you multiply two conjugates, you notice that when we distribute this, we're going to get 9 minus 3 cubic root of 5. I'm sorry, plus 3 cubic root of 5 minus 3 cubic root of 5. And when you multiply the square roots, did I say cubic root? I think it's square root. Anyway, 3 times 3 is 9. 3 times the square root of 5 is 3 square root of 5. Negative square root of 5 times 3 makes negative 3 square root of 5. And the square root of 5 by itself, multiplied by itself, is going to give us 5, but it's negative. So this simplifies into 9. And notice how both of these cancel or add up to 0, and then minus 5. So these multiply to exactly 4. So something you want to notice is that when you multiply two conjugates, the square roots disappear. There's no more roots on the product. And so that's exactly why we do the following. In order for us to simplify expressions numbers 3 and 4 here, we're going to multiply everything top and bottom by the conjugate of the denominator. When we do that, on the right side, on the numerator, we're going to get 6 and then 2 square root of 5. And on the bottom, I already show you that the product of these two conjugates is going to give us just a 4. Okay, so 6 plus 2 square root of 5 divided by 4 is the answer. But notice how this is the same thing as 6 over 4 plus 2 over 4 square root of 5, which in turn turn into this. 1 over 2 square root of 1 over 2 square root of 5, or square root of 5 over 2. And that would be the simplified form. Okay, so another one from scratch. what we do here is we're going to multiply top and bottom by the conjugate. And to find the conjugate, all we have to do is change the sign in between the sign in the middle. Notice again, this is going to give us 5 square root of 2, 5 square root of 3. And the shortcut for multiplying conjugates, it's as simple as this. You square the first number and you get 2. You square the second number and you get 3. And then you put a minus sign between them. So this answer is going to be 5 square root of 2 minus 5 square root of 3 over negative 1, which is going to simplify into negative 5 square root of 2 plus 5 square root of 3. And that's the answer, as long as we don't have no radicals, no roots on the denominator. Okay, so that's it. So, please pause this video, try this problems on your own, find some other ones that you could try. But it's as simple as multiplying top and bottom by the conjugate. Just be careful how you multiply the conjugates. To do the next set of problems, all we have to do is consider, when we have negative 2 of something and then 30 of the same exact thing, all we have to do is subtract. It's like taking 30 apples minus 2 apples. You're going to get 28 apples, right? In this case, 28 cubic root of 5. It's as simple as that. Sounds a lot more complicated, looks a lot more complicated than that, but it is exactly that. So we'll just put together the like terms, or in this case again, 30 apples minus 2 apples, 28 apples. To do the next one, we can't do exactly the same thing because we don't have the square root of 6 or the square root of 54 on both of them. But I do know that 54 is the same thing as 9 times 6. And by a property of square roots, this is really 2 times 3 square root of 6, because the square root of 9 is 3. And so that's going to give us 6 square root of 6. And so what we do here is we have 6 square root of 6 minus 11 square root of 6. Think about it as, you have 6 of something minus 11 of something. That's going to give us negative 5 of that same thing. And that's how you simplify these type of radicals. Please keep practicing, keep watching videos, keep asking questions, and do these examples on your own a couple of times. You're going to see how you understand it completely. I'll see you next time.